Okay, we're picking up with example 4. In this problem, we're going to be solving polynomial functions by factoring, and this is obviously a real-world problem. So this problem says we need to determine the dimensions of the cubes below if the length of the smaller cube is half the length of the larger cube, and the volume of the shaded figure is 23,625 cubic centimeters. So you can see that they've set this up and they show that this smaller cube, all of its dimensions are x, and the larger cube is 2x because it's twice as big, since the smaller cube is half the length. Each length of the smaller cube is half the length of the larger cube. So what we know is the larger cube, the volume would be one side cubed. So the larger cube is 2x cubed minus x cubed, since we're subtracting out the smaller unshaded piece. And we knew the total area or volume was 23,625. Let's go back and look at that picture again. We're doing the volume of this whole large cube and subtracting out this little piece. And our leftover, all the shaded stuff, is this 23,625. So we're going to cube 2x and we get 8x cubed. Then we have like terms here, so this simplifies to 7x cubed. We're going to divide both sides by 7. We get this number, and then on the next screen we're going to have to take the cube root of that number. Oh. Well, the cube root of 3375 could be 15, but we're going to use the difference of cubes right here. 3375, I believe it's a perfect cube. Yeah, it's 15 to the third power, so that's how this x minus 15 can factor out. So right here, this is just using the formula from the beginning of the lesson. So we're curious, when does x minus 15 equal 0? And I've noticed that they have made a mistake here. This should be positive 15, because 15 minus 15 gives us 0. Or this second piece could also give us 0. And from this second piece, we get this crazy number right here, negative 7.5 plus or minus 7.5 I root 2. That's not going to be any good for us, because it's got imaginary numbers in it, and we can't deal with imaginary side lengths. So our answer is 15, so that means the smaller cube, each of the lengths of the sides of the smaller cube is 15 centimeters, and the larger cube is twice as big, so it's 30 centimeters on each side. Okay, here's a problem for you guys to check your progress on. Pretty much the same basic concept. Pause the video and work on this as long as you need. When you have an answer, go ahead and check out the next slide. Okay, our answer for this one is B. The smaller cube is 9 centimeters on each side, and the larger one is 18 centimeters on each side. One more key concept is about quadratic form. It says an expression that is in quadratic form can be written as AU squared plus BU plus C for any numbers A, B, and C, where U is some expression in X. So basically the concept here, here's an example. 12x to the 6 plus 8x to the 6 plus 1. We can turn this into some kind of a quadratic. If we look at x to the 6, if we look at 12x to the 6 and 8x to the 6, and we find that the greatest common factor of those two terms happens to be 2x to the third, so we're going to express this 12x to the 6th as 2x cubed squared, so we have a square plus another square plus 1. Alright, so let's look and see if we can do this with an example. We have 2x to the 6th minus x to the third plus 9. And we're going to try to write that in quadratic form if possible. So what we notice here is that this 2x to the 6th, we can say that is the same as 2x cubed squared. We're looking for x cubed because we see an x cubed here. And so we know that this, because of our exponent properties, if we do 3 times 2, we'll get the 6. So let's keep moving. Oh, okay. So that's quadratic form. The concept here is that you're going to have, let me write out a basic quadratic. Back in Unit 1, we talked about quadratics as being ax squared plus bx plus c. So this quadratic form that we're talking about now is basically saying you're trying to make something that looks like this, but instead of just a plain old x, we might have a more complicated expression. So here we have x cubed taking the place of our just basic x from down here. Instead of x, we're using x cubed. But other than that, it looks the exact same. This is 2 times something squared, a times something squared, plus or minus, same difference, something, so plus a number times something, plus another number, plus a c. So we put this in quadratic form. Part B, let's see if we can put this one in quadratic form. So again, because we see this cube here, we're hoping that this first term is a cube squared, but this would be 3 times 2 power, which would give us 6, and we don't have a 6 here, we've got a 4, so we can't write this in quadratic form. So basically, to simplify all this, you're hoping for this first exponent to be twice as big as this second exponent. Before, in part A, we had 6 and 3. 6 is twice as big as 3. 4 and 3 for this part. Obviously, 4 is not twice as big as 3. All right, so check your progress problems. Pause the video, and then when you have your answer, go and check the answer on the next slide. Okay, our answer to part A is letter C. And part B, pause the video, work out your solution, and then come back when you have your answer. Okay, part B, our answer is D. You cannot write this in quadratic form. All right, last example, example 6. In this one, we're going to be solving equations in quadratic form. So we're going to try to express this as a quadratic form and then solve the equation. Notice how the 4 is twice as big as this. So we're going to be able to write this in quadratic form. X to the 4th is the same as x squared squared. So what we're doing here, this is something called U substitution, which you might learn about you'll learn about a whole lot more of this if you go to calculus. But for right now, it's pretty basic. We're just going to take the x squared and we're going to replace it with a simpler variable. You can pick U if you want. You can pick another letter. It doesn't really matter. But when you do that, it's going to make this problem seem a lot simpler for you. So we're taking this, we'd have u squared minus 29u plus 100, and we're looking for two numbers that multiply to be positive 100 and add to be negative 29. And in this case, our answers are negative 25 and negative 4, because negative 25 times negative 4 gives us positive 100, and negative 25 plus negative 4 gives us this negative 29. So as our two factors, we're going to break it up, u minus 25 and u minus 4. Gives us our answers of 25 and 4. Once you have that, you need to go back and replace your u with the x squared. So we have x squared is 25 and x squared is 4, and then we're going to solve for x on this next slide. We do that by taking the square root and then simplifying our root. So we have plus or minus 5 and plus or minus 2. So we have 4 solutions to this equation. If you think back to the beginning of the slide, there was a 4th power problem, so it would make sense that there would be 4 solutions to the problem. Just like earlier this year when we did quadratics, 2nd power problems had 2 solutions. Alright, check your progress problem. Pause the video as long as you need, and when you have your answer, come on back to this. Answer should pop out to you pretty quickly though. Okay, our answer to this problem is A. It's not -2 and -3. If you're unsure about this, you can ask me in class and we can go over why this problem only has 2 answers instead of 4. Alright, that's the end of Unit 2, Lesson 4 on solving polynomial equations.